Yeah, but to teach you this skill, we're going to talk about some realistic situations that you wouldn't necessarily have to use this skill, but it will help you understand what we're doing and have that, quote-unquote light bulb moment. So, in our previous sections, we've talked about all these different types of special parabolas. And one that we've looked at is a perfect square. But when we've looked at that, we've had these perfect square situations equal to 0. Like it's quadratic form. So like x minus 3 squared equals 0. Or x, whatever, something, a binomial squared equals 0. Right? But what about if it didn't equal 0? And those weren't our 0 points. Like they weren't our x-intercepts, right? Because there are x-intercepts because it equals 0. The y value is 0. Y wasn't 0. It's not our intercepts. And what then does it tell us? That was more of a hypothetical question, I guess. Rhetorical, thank you. It was more just to get our wheels of our brain turning.
Okay.
So, go ahead and label 59 on your paper. We gotta help Ernie out. And by Ernie, I mean Chelsea, my wife. She wants a hot tub. Let's just spin it this way. And all of my friends think that we should put in a hot tub because I just put in a patio, and they're all like, what your patio needs is a hot tub. I'm like, my electric bill does not need a hot tub. So, Ernie likes to go big and has decided we're getting the biggest hot tub possible.
Why?
Except we live in the real world, and there are constraints such as how big is your space. So you can't buy a hot tub bigger than your space. As cool as it sounds, you don't even have graph paper out yet. Can you get with us? I was giving you some time, but now I literally can't focus because you're making noise. So go ahead and read through this. Just A. So, I want you to draw a square on your paper, big enough that we can make a sketch of what's going on here. We're going to have a hot tub, and it's going to bump into a corner of our area. And on two sides of the hot tub, there will be a 3-foot wide deck. Ernie figures that that's enough space to walk, have a couple chairs, be able to set your snacks on while you're sitting in the hot tub. You don't? I don't hang out in hot tubs. I think you guys can solve this without me. A couple of you probably have already solved it.
I think I get it. It's 3-foot wide deck on 2.
Ernie doesn't have a measuring tape. Doesn't even own one. However, the people that installed his patio told him that it's 169 square feet.
And it's a square shape.
It's a square shape. My patio is not perfectly square, but I don't like perfect square things. They don't look natural.
No.
Perfectly square is not natural. No. There's nothing perfect in nature.
Wouldn't it be like a 10 by 10 hot tub? Because then you have a 3-foot wide deck on 2 adjacent sides, so. Yeah, right? It'd be a 3 by 3. 10. Wait, 3-foot wide? 2 sides. Okay. Wide? Okay. So I did it the opposite way.
Liang. 2 adjacent sides. Not 2 sides, but adjacent next to each side. So it's got to be connected, right? 2 adjacent. Yeah, read carefully, guys. Sorry, I knew that was a trap door that some of you would fall into. But square hot tub going into a square space, it has to nestle in the corner and have the deck parts be like an L, right? It's got to be adjacent edges. So, Sammy, talk out what you were thinking. You were trying to talk to me, but you don't need to talk to me. You need to talk to the classmates.
I thought since it was 13 by 13 feet of space, and it needed a 3-foot side, like 3-foot wide deck on 2 of the sides.
No, wait, how'd you know it was a 13 by 13 space?
Because
69 squared.
square root of 169.
Mm.
So it'd be 13 by 13. And if he needs 3 feet on 2 sides, then it's 10 by 10 foot hot tub.
So wait, so that's not that hard then, right? So
No.
you said we had a square, and according to your drawing, we do something like this. Sorry if things don't look perfectly square. It's the resolution difference between that monitor and this monitor. It gets a little funky. So we said the whole thing, you have to just imagine with me that this is square, is 169. And it is square, so we essentially said x and x, or z and z, I guess if you want to say. So z squared, some dimension, is 169. And, you know, you guys are all very smart people, so you figured out pretty quickly 13 squared is what satisfies 169. Which means if this is 3 and this is 3, that these have to be 10. So really what we had, if we write this out, is x plus 3 squared equal to 169.
X equals 10 in this scenario,
Right, and really, you should write this out for when it gets harder. Really what we did, should we start by squaring that binomial? Or is that what Sammy thought through, was squaring that binomial? Did Sammy do, you know, x squared plus 6x plus 9 and then work that? No, what'd she do? So she square rooted both sides because this makes it more complicated. Right? Squaring a binomial, it actually brings in 2 variables instead of just 1. Right? X and x squared are essentially 2 different variables. Even though they use the same input, they're different. So this lets us get to x plus 3 equals 13. And if we're being technical, it's positive or negative. If we're being precise, you should write this. It's positive or negative because square roots have positive and negative roots. In this scenario, yes, agreed, sir. So we get negative 3 plus or minus 13. Now, in this scenario, the negative 13 wouldn't make any sense. Or the minus 13, I guess, if we're going to say it like that. So we can rule that out. But if we were talking technically, we have 2 answers. It's negative 16 or 10. Then we go and say, okay, well, that's silly. Although it was a possible answer, quote unquote.
If we did it,
If we actually graphed this, that would be another one of our answers. So these aren't zeros. These are our 169s. Right? Because this, if we made it a parabola, perfect square, wait, well, we're not, well, it's equal to 169. Maybe we shouldn't talk about that. But what we're saying is there's a point up here. There's a point over here. Now, this parabola is not perfectly centered, but we'll get to that, right? But there, we're not finding zeros, right? We're finding 169s, right? So this is what we're talking about. Kind of like zeros, but not quite.
wait, so when are we gonna get into like the thing that has like the how it bounces?
Oh yeah, you told us that thing where it's
What?
like
Oh, we'll
the
get there.
focus and it's like light.
We'll
It's like,
get
oh my gosh,
I-
I love light.
I thought you only knew we were doing it was.
No, well, I don't know.
She just wanted to build up
We'll
the-
naturally get there. Don't you worry. Don't you worry about it.
Oh.
All right, so if we go back to B. You don't know that song? I'm sorry.
I do know
I know
that.
that.
You guys may use the board if you want. I would like you to process through B. It is slightly more difficult. Does this only have something on two sides?
No.
No, it has that frame on all four sides, right? Because I know I'm potentially faster at this up here, if you would like for your picture. Here's Gabby's whole space. Right, and then I'll make a smaller square inside of it.
That's 6 inches.
Yeah, I might this weekend actually try to switch my monitors, which involves a lot of me holding my breath and crossing my fingers, but to try to fix that resolution issue of that looking not.
Wait, okay, then what are you doing? Oh,
It's 12 square feet.
Yeah. Oh, 12 square feet. I read that wrong.
It's not 12 feet.
I was like
squared. Like, so guys, rock garden, right? If you've never seen like a Chinese Zen garden or anything, we're not talking huge. We're talking this space. She's got a little area in her backyard. It's 12 square feet. We aren't given the dimensions right now because this one's harder.
So once the whole garden is covered 12 square feet.
Garden and frame.
If the frame rock garden is square, how much?
Well, that's gonna be a weird desk.
Putting the decorative rocks in the 12 feet square area, right?
Yes, but inside the frame.
Wait, inside the mini square or inside the frame?
The mini square. Why would you put the rocks in the frame?
I don't know what
The frame is to hold the rocks.
I knew this was going to hang us up because this is what we get hung up on in this class. The area of this object
is like 6 by 6.
No, it is 12 units, 12 feet square. You actually know the units.
Okay.
If it's a square, sure, we could derive what the edge lengths actually are, but that's not what we care about quite yet. This, I'm actually going to use brown. You'll understand in a minute.
Oh, is that for the frame?
This, oh, yes, okay, is a wooden frame that is 6 inches wide. Right, so 6 inches wide here, 6 inches wide here, 6 inches wide there, and 6 inches wide here, meaning from there to there, 6 inches.
Okay, I did something wrong. So wouldn't it, then the inside square would be 11? Because, no, it's not. Okay,
Let's call it R by R for rocks, right? The rock area will be R by R.
Okay, so we know the area. Are you talking about the area of everything?
The area of the blue.
Okay.
Blue squared area is 12 square feet.
And we need to find what the inside area. Well, couldn't we just like move the square into like the corner and make it a foot by foot, and then we'd know the inside, and it'd be easier.
So you're saying change our drawing, doesn't change the math.
Yeah,
You're saying change our drawing
so
to
it's
do
easier to like think about.
this,
Yeah.
and then you said this is going to be a 1
Yeah,
and a 1, so we have R plus 1
so
and
wouldn't
R
11 by 11?
plus 1.
Wouldn't that like what?
But we don't know how long R is. So how could you
Who said what? Is there confusion of how we moved the box and then made it a 1?
It's like the box, but how do you know it's plus
Oh,
one
wait.
if you don't know how long
Because this
R
was
is?
6 inches and this was 6 inches.
Yeah.
So when Sammy pushed it this way, that 6 inches came over here.
Okay.
6 inches and 6 inches,
So would it be
1
11
foot.
because I was doing 12
Okay,
So now she changed her units to all be feet, right? Because instead of working 6 inches, which is annoying since this is in feet, and I was waiting for somebody to tell me that I shouldn't be using a 6 or I should change, like, but now that she put it into feet, we're kind of okay now. Because everything's in feet. All right, so hold on. Are we all okay with how Sammy was allowed to move that box and change it into r plus 1 and r plus 1 instead of 6 plus r plus 6 or 1/2 plus r plus 1/2? Like, she grouped her like terms. Or she grouped her constants. The length of the wood frame was 1/2 plus r plus 1/2. That's annoying. It's really r plus 1. Right? Like, let's make things easy. Exactly what David said. I thought mathematicians wanted to make things easy. So the hot tub was the easy part. Rock gardens are a little rocky.
So,
the inside is r squared. Why doesn't she just buy a bunch of rocks if she over like?
wouldn't it be like? It'd be R would be like 2.1.
Okay, because that
Not
side
2.46.
r plus 1
Because
a square should equal 12 feet, right?
yes.
Yeah.
So it's like 2.46 plus 1. It wouldn't be 11.
Yeah,
Because then it'd be 12 by 12.
So wait.
Times 12, not
Wait. What's our area?
12.
Now, what else could we say for our area? None. Not actually.
You could if you wanted to. It's probably not going to happen.
It's r squared.
It's what?
R plus 1 squared.
I can replace this A with r plus 1 squared.
We do what we did last time with the x plus 3 squared. Ah.
Sounds like we're all at the dentist's office.
I don't know if people actually do that.
What? Go off? And when they ask you to.
I don't go.
You just open your mouth.
Just open your mouth. You don't go like,
Don't make it awkward. That is just a possibility. Okay, let's just do the math.
I just got a really weird voice now.
Plus 2r. Okay, so 12 equals r squared plus 2.
the square root.
So r squared equals 10.
Yeah.
So you just do the square root of 10.
The square root of, no, why would you do the square root of 10? The square root of 11.
Oh shoot. I made a mistake. I'm sorry. 1 squared does
No,
not
wait.
equal 2.
Why would you do the square root of 11? Wouldn't you do like the square root of 2 and then take away 1?
Okay, so it's like 1 squared. Subtract 1 on both sides.
Figure it out. I'm not going to tell you which way is right.
Oh, never mind. I was
Okay.
doing the
You want
square
this?
root.
Stripping us up, you guys.
I thought you were going to go to the board and be like, shut up, guys. This is how you do it.
Okay, instead of doing the
Yeah, you are, Athena. You did the best on that last mastery for what it's
Did
worth.
she get an E?
I don't think I gave out any E's.
Instead of doing
To get an E is pretty tough for me in this class.
David did use the put the 2 squared to the r and the 1. I just do the square root of 12 and the square root of r plus. But if you
That's a weird number.
Wait, hold on. The same.
11. Okay, so it's just like, did you guys get like 3 points?
If I'm totally lost and I hand you $20 to talk me through this problem,
Okay.
right?
Good.
And I just don't understand what you're doing or saying, tell me what.
You're getting it wrong.
No. But like, so say I'm a classmate and I'm like, I just totally don't get this. What are you writing here?
First, we say there is a comma.
So
No, what are we like to the
Okay.
work that?
So-
So say I'm trying to like write stuff so my teacher gives me points. Right? You're trying to talk a classmate through this.
okay, wait,
Be
guys.
really
Wait, I
explicit,
just
like
gotta say
really
something.
clear. What do we do
Okay.
here?
Wait, I just want to say something. You guys was like doing the taking away. I see what I did. R1 squared. Wouldn't you do the square root? Because if you do the 1 squared and do this like -1, and then what like David did,
Did I do it?
you'd get like 3.3, and 3.3 times 3.3 is 12.
You're right.
I know. I see what we. So wouldn't you just do the square root of r plus 1 and the square root of 12?
That's what I did.
And then subtract the 1, and then that's r.
Wait,
Yeah,
walk me through this.
R is
Square
about
root.
2.46. So you that's the wrong step.
Oh, you did the square root of 12, which is equal to r plus 1.
Yes.
Okay, got
You
it.
guys were doing the distributive property of the square root instead of just
Ooh.
squaring both of them.
Yeah, and we can't distribute the square,
Because then you'll
right?
won't
It
get
actually
the-
foils.
See, I didn't do
If
it.
you distribute the square, all you're doing is full,
So it's
There's
actually
no O and I,
4, 6,
right?
Right.
This, I was trying to get you guys to tell me to write a square root symbol around both sides. So if I square root both sides, that breaks the parentheses off of this, right? Because the things were stuck in it, but now we got rid of them. And positive or negative radical 12,
Again.
right?
Oh, yeah,
Do not
positive or
forget
negative.
about those options.
Mm.
Now what do we do?
You do the math.
You take away one from
3.46.
both sides. No, you don't. You do this.
Yeah, so
You
are
could do
equals positive or negative?
Okay, we're doing that.
Yeah? You said take away one from both sides?
this. And then wouldn't you simplify it?
If
Be like the
asked
decimal?
to write it as a decimal. Now this again is where we're going to use your calculator as a hack. Type in exactly what I have here. Parentheses negative, well you don't even need the parentheses around the negative. But -1, but then just hit plus radical 12.
Yeah, okay.
Type in -1 plus radical 12, hit enter,
And you
you get 2.464.
Wait,
And then second entry.
Then second entry, change the plus to a minus.
I am so wait. What? Okay, I did the first one.
Then hit second entry, so it plugs in again.
Negative
And
4.
change the plus to
Wait,
a
it's
minus
negative 4.4 blah
on
blah.
the entry.
Oh,
Yeah.
Okay, cool. I did it right.
entry.
I think.
And you should get negative
4.4.
4.46.
I did it.
But that makes no sense.
All right, so a vocab word that I need to start using because I realize it as I tutor Math 3 people. Oh, by the way, that's also why I overteach. I tutor Math 3, so I know what you're going to do next year.
So like you tutor people at the library?
And like weekly. So I have 2 students in Honors Math 3 right now that I'm tutoring, and I know what you're going to be asked to do next year.
Are they in high school?
Tutoring?
Yeah.
What even is like? Is it just like extra
You
work?
meet and you work on whatever they need to work on. I teach them differently than their teachers have taught them, and with the individual attention they deserve, which you guys already pretty much get because of how small group the setting is. You
So
like
if they don't get it in a
technically
big
this
class.
class shouldn't exist. For one teacher to teach 5 kids is not the appropriate use of an FTE, which an FTE is I'm a 1 FTE. I'm a full-time employee FTE, and I'm broken up into job responsibilities, right? Kids that I teach, a class of 5 shouldn't exist. That's why we at Phoenix fight for those things to keep you here instead of sending you to the high school. You're getting more attention than most kids get at school, like in a math class or in a
Because if
class.
you're sent to a big class, you get less attention.
I'd be
This,
more confused.
please write this on your paper because it's a vocab word you're going to start to see next year, is what we call an extraneous solution. It is a solution, but it doesn't make any sense because that's why it's extraneous. Like erroneous, if you ever erroneous. Like extraneous is like, well, sure. Excuse me, it's just funny. Mathematically,
It's true. But
it's true.
in real life, it wouldn't.
But you're going to tell her to make the frame of her rock area negative 4.46 feet, and she's going to commit you to a psych ward. There are no negative lengths. So this only has one realistic solution. It also has an extraneous, which if you're asked to give both, you need to give both.
Should you give both?
This
even if they don't ask for both?
is both solutions. This is both solutions. The realistic and the extraneous. So if you're told to write it in radical form, this is it. You're done.
If they don't, should we give them both, even if they
Yeah,
don't ask?
probably. Most things that are going to ask you to do this will be very specific of write your answer in radical form or write your answer as a decimal. Answer as a decimal. Right? So extraneous solutions are solutions that do exist but don't make sense. All right, so moving on. Try these real quick now that we know the process. Yep. We square root first.
Yeah.
Square root first, then do the algebraic arithmetic. Because the square root is also algebra. I'm going to check how long we're in here. 30. We're out here at 30 today. Yeah, there are two answers.
Oh my goodness.
A lot of people also just write it as two answers, so x equals 3, comma, x equals negative 1.
I just did x equals negative 3, comma 1.
Dangerous thing with that is people will start to look at that as a point. If they're not as, like, with you, if they're not, like, knowing what you're doing, finding multiple solutions, a number, comma, another number, which I know, we've written it like that. I'm just telling you where that gets dangerous. People will see that as a point, potentially. So that's why sometimes we'll write or, sometimes we'll write them separately.
I don't think C is possible. Well, I'm not. Negative 4. So it's not possible.
My eyes aren't that expressive.
Just use imaginary numbers.
That
That
not
is fine.
X. Oh, square root of 0, 0, right? So wait, is there only one solution here?
Yeah. Because 0
Oh,
can
it's
be
the
negative
0.
or positive.
It's the 0.
It's
It's the x-intercept. Yeah, because it's the 0. This is like what we've already done. This is what we hadn't done until today, right? We had done this. That's why you're trying to see with B. And then C.
Not possible. Oh, wait, because it could be plus or minus the square root. Oh, never mind.
I love you, but I'm honest with you. Don't let yourself be like, oh, okay, sure, and not actually know why.
Why
So-
is it then? Why is it like this?
But you can't do that.
or can't yeah.
Not yet, until we're in smart method.
I equal like negative 1.
I'm not smart enough for this yet.
Can you explain why it works like that then?
Because math numbers, that's why.
The square root of a value is the value that when multiplied by itself equals the number we started with, right? So the square root of 4 is 2, because 2 times 2 is 4, but also negative 2, because negative 2 times negative 2 is 4. This is where square rooting negative numbers is a giant pain in the patootie. So we need a number when multiplied by itself that makes a negative.
Imaginary.
And since all of math is pretty much made up anyways,
Why not make up
That is
some
true.
more?
mathematicians decided it's time to make up a way to handle these situations, because it's not that this can't happen. It's that we didn't know how to make it happen.
Make a new type of
You
number.
weren't smart enough yet. So, I want to make sure I get this right to give credit where credit is due. And if you get really interested in this, you are welcome to borrow this. I bought this. It is from a website that, like, it's a Wolfram Alpha thing, but they sell this as like a unit. Wolfram Alpha. Wolfram Alpha is like a math. If you search Wolfram Alpha, it's like the calculator that you can type in anything sort of thing. And if you type it in law, it will figure out an answer. Like how many swallows would equal a whale, sort of thing. Like a weight of a swallow versus the weight of a whale. So, Raphael Bombelli, right, who lived back in the 1500s, decided to take it upon himself to say, well, okay, if we can square root all these other numbers, why can't we square root -1? Because really, this could be thought of as the square root of -1 times the square root of 4. Go ahead and make like a little a side box, like a blowout, a thing that doesn't necessarily follow these problems, but it relates to it. An adjacent note, if you will. Any square roots that are multiplied by each other can be written like that or like this. This does not work for addition. So if you had square root of 2 plus 3, like all under the square root, you cannot break that into square root 2 plus square root.
Wouldn't you have to like add 2 plus 3 together and then do
Yes. So we can break the multiplication and write it as 2 different square roots. So Bombelli was like, well, shoot, man. If you just square root this, we can just leave the radical -1, right? I mean, it's the messy thing that we don't want to deal with. So for a while, and I'm making some of this up just to like tell the story. For a while, mathematicians were just saying, okay, so our solution here is x equals the +1 plus or minus the quantity. Well, the square root of 4 is 2, right? 2 times the radical -1. And they didn't really love that, right? They're like, well, that's okay. Bombelli, you are the bomb, but it's still not. It was that mathematician, Bombelli. So Bombelli's like, you know what, guys? People keep spelling my name wrong. They think it's Bombelli. It's not. It's Bombelli. Now that part's 100% made up. But I do not want you to think that I stands for imaginary numbers, because that's what people will tell you. That's a lie. Because imaginary means something that's not real. Right? You know, this might be a thing in kid culture. Anyone know about topas? So I was listening to that podcast that I'm into, and apparently there's this whole like culture around like essentially adult imaginary friends, but it's like writers that their characters have become so real in their mind that they've like come to life. Yes, apparently this is a real thing. I am like this. I'm being honest. So that's imaginary, right? And that is somewhat concerning, actually, depending on where you stand on like mental health things. Math is not, right? Math is a system. It's a process. We do it. It's not imaginary. So I don't want you to think I is the imaginary number. I is the placeholder for square root of -1. Because for a long time, people were very upset that we couldn't do this math, and now we can do this math. Well, you're using an imaginary number. It's a number we made up, but it's not imaginary. It exists.
So it's kind of
Did
like
we watch the imaginary numbers are real video already? I think we watched a piece of it. So last thing we're going to do as we start talking about I is if you've already seen this, that's fine. We're going to rewatch it because now it will make a little bit more sense.
So like when I squared. Oh, wait a minute.
We did watch this, but it didn't make sense back then.
Oh no.
Oh, that thing?
Where the function crosses the x-axis. As we can see, our parabola actually never crosses the x-axis. So according to our plot, there are no solutions to the equation x squared plus 1. And Gauss's discovery is not just some random rule. Today we call it the fundamental theorem of algebra.
Gauss is who made
So our plot
that.
seems to disagree with something so important. It's called the fundamental theorem of algebra, which might be a problem. What Gauss is telling us here is that there are two perfectly good values of x that we could plug into our function and get 0 out. Where could these two missing roots be? The short answer here is that we don't have enough numbers.
So what Gauss said was there has to be an answer, right? Like if we can write it and solve it and not break any rules, it has to solve. Right? Because Gauss is a very smart mathematician. People will like scratch their head and they're like, huh, okay, he's smarter than I am. there must be an answer. So then mathematicians went back at it, and they're like, well, okay, if Gauss said there has to be an answer, let's figure it
What
out.
if we think of numbers existing on a one-dimensional continuum, the number line? All our friends are here. 0, 1, negative numbers, fractions, and even irrational numbers like root 2 show up. But this system is incomplete. And our missing numbers are not just further left or right. They live in a whole new dimension. Algebraically, this new dimension has everything to do with a problem that was considered impossible for over 2,000 years. The square root of -1. When we include this missing dimension in our analysis, our parabola gets way more interesting. Now that our input numbers are in their full two-dimensional form, we can see how our function x squared plus 1 really behaves. Our function does cross the x-axis. We were just looking in the wrong dimension. So why is this extra dimension that numbers possess not common knowledge? Part of the reason is that it has been given a terrible, terrible name. A name that suggests that these numbers aren't even real. In fact, Gauss himself had something to say about this naming convention.
Such an obscurity would have been out of the
So
question.
yes, our missing dimension is
Why
comprised of
did
numbers
people
that have been given the
name it
ridiculous name imaginary. Gauss proposed these numbers should instead be given the name lateral, so from here on, let's let lateral mean imaginary. To get a better handle on imaginary, I mean lateral numbers, and really understand what's going on here, let's spend a little more time thinking about numbers themselves. Early humans really only had use for the natural numbers, that is 1, 2, 3, and so on. This makes sense because of how numbers were used. So to early humans, the number line would have just been a series of dots. As civilizations advanced, people needed answers to more sophisticated math questions, like when to plant seeds, how to divide land, and how to keep track of financial transactions. The natural numbers just weren't cutting it anymore, so the Egyptians innovated and developed a new high-tech solution: fractions.
Remember, we made
Fractions
this all
filled
up.
the gaps in our number line and were basically cutting-edge technology for a couple thousand years. The next big innovations to hit the number line were the numbers 0 and negative numbers, but it took some time to get everyone on board. Since it's not obvious what these numbers mean or how they fit into the real world,
Remember, different
0
cultures
and
were
negative
developing
numbers were met
math
with
at the same
skepticism
time.
and largely avoided or ignored. Some cultures were more suspicious than others, depending largely on how people viewed the connection between mathematics and reality. And this is not all ancient history. Just a few centuries ago, mathematicians would intentionally move terms around to avoid having negatives show up in their equations. Suspicion of 0 and negative numbers did eventually fade, partially because negatives are useful for expressing concepts like debt, but mostly just because negatives kept sneaking into mathematics. It turns out there's a whole lot of math you just can't do if you don't allow negative numbers to play.
Alright, so if you're interested in this, it's like the top search essentially for imaginary numbers are real. Guys, this blew my mind. Like quite literally, I had to watch this video multiple times as an adult trying to teach this content. Like, it's complicated. Right? So I'm not like telling you this as like some hoity-toity, like, it's not a big deal. It's a big deal. And it is complicated. We're gonna take some time to dig into this, but please do not operate saying imaginary and thinking they're not real. These numbers exist. They're perfectly usable values because we invented all of math, right? And the other thing that I want to keep us thinking about, and I teach relatively the same things every year, but humans are still relatively young. Like in the grand scheme of like how long we've been on Earth, we're still figuring this stuff out. So the fact that something couldn't be done for 2,000 years, okay, fine, but then we figured it out, and everything changes, right? Okay, get out of here. I know I've lost you.
What was the dimension called? The lateral dimension?
Lateral dimension, yeah, because so instead of thinking all numbers exist right here, there are also numbers here, like think about the y-axis, that are manipulations of the rational numbers that we're used to.
So like, it looks like this will get up.
So imagine, so you go out to 3, right? And then we have 3 and another value with 3. Picture it like an XY point. That makes it. We'll talk more about it next week. Not ready. What? It's not imaginary. It is the number I, but it is not imaginary.